Hello everyone, this is Kalpana here. In this video, we're going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square plus 4d minus 12 into y equals to x minus 1 into e power 2x. Firstly, let's find the order and degree of the given differential equation. Identify the highest derivative. Here d square is the highest derivative, so our order will be 2. And highest power of the highest derivative is a degree is 1. Or just write the given differential equation as d square y plus 4dy minus 12y equals to x minus 1 into e power 2x. We know that d is a differential operator. Then d square will be d square by dx square. Now we can write this equation as d square y by dx square plus 4 into dy by dx minus 12y equals to x minus 1 into e power 2x. Here d square y by dx square is the highest derivative, so our order will be 2. And highest power of the highest derivative is a degree is 1. Right? Now coming to the problem. Given differential equation, d square plus 4d minus 12 into y equals to x minus 1 into e power 2x, which is an operator form. F of d into y equals to q, where f of d equals to d square plus 4d minus 12 and q equals to x minus 1 into e power 2x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp, where yc is a complementary function and yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by putting RHS to 0, we'll get f of d into y equals to 0, which is our homogeneous equation of the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Okay, so firstly we'll find yc and later we'll go for yp. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square plus 4d minus 12, right? So let's replace the differential operator with m, so that we'll get f of m equals to m square plus 4m minus 12. Then our auxiliary equation becomes m square plus 4m minus 12 equals to 0. We can write 4m as plus 6m minus 2m. Now take m common from the first two terms, we'll get m times m plus 6, and take minus 2 common from the next two terms, we'll get minus 2 times m plus 6 equals to 0. So we are having m plus 6 in both the terms, so let's take m plus 6 common, we'll get m plus 6 into m minus 2 equals to 0. Now equate each factor to 0. M plus 6 equals to 0. M minus 2 equals to 0. From m plus 6 equals to 0, we'll get m equals to minus 6. And from m minus 2 equals to 0, we'll get m equals to 2. Right? Then m equals to minus 6 and 2 are the roots of our auxiliary equation, which are real and distinct, or we can call them as real and different. Therefore, m equals to minus 6, 2 are the roots of our auxiliary equation, which are real and distinct. We know that when two roots, say m1 and m2, are real and distinct, then complementary function will be one constant into e power 1 root into x plus another constant into e power another root into x. Now let's write the complementary function of our problem. Our complementary function looks like one constant into e power 1 root into x plus another constant into e power another root into x. Then yc will be c1 e power minus 6 into x is minus 6x plus c2 e power 2 into x 2x. Right? We got our yc. Now let's find yp, particular integral. We can find particular integral using 1 by f of d into q. We have f of d and q where f of d is d square plus 4d minus 12 and q is x minus 1 into e power 2x. And this of 1 by f of d into e power ax into v form. We'll shift e power ax towards left by replacing d, differential operator, with d plus a, and later we'll operate v with 1 by f of d plus a. Right? So now for compare e power 2x with e power ax, and for a equals to 2 we'll find d plus a, which is equals to d plus 2. Right? Now let's just take this e power 2x towards, shift e power 2x towards left, we'll get e power 2x into 1 by, replace d with d plus 2, we'll get d plus 2 whole square plus 4 into d plus 2 minus 12 into x minus 1 is equals to e power 2x into 1 by, expand d plus 2 whole square, we'll get d square plus 2 square 4 plus 4d plus 4d plus 4 2s are 8 minus 12 into x minus 1. This becomes e power 2x into 1 by d square plus 4d is 8d plus 4 plus 8 plus 12 minus 12 into x minus 1. Here plus 12 minus 12 gets cancelled is equals to e power 2x into 1 by d square plus 8d into x minus 1. Now let's take d common from the two terms of denominator. We'll get d times d plus 8 into x minus 1. Now we can split this fraction as e power 2x into 1 by d into 1 by d plus 8 into x minus 1. Right? So this is equals to e power 2x into 1 by d into, so this is of 1 by some function of d into x power k form. Okay. So now we can write the denominator as, or this fraction as, 1 by some x plus 1 or 1 by x minus x minus 1 form. Okay. So here what we are going to do is, we are having the denominator of descending order. Right? Let's take the lowest degree term common from these two terms. But for d, we don't have any 8. So what we'll do is, we'll just multiply and divide d8 to this d. Okay. So that it will be easy to take 8 common from these two terms in the next step. Okay. This becomes e power 2x into 1 by d into 1 by, now take 8 common from these two terms, we'll get 8 into d by 8 plus 1. Okay. See, if we take 8 common, we'll get 1 by 8 into d, which we can write it as d by 8 plus 1 into x minus 1 is equals to e power 2x into 1 by d into 1 by 8 into, we can write d by 8 plus 1 as 1 plus d by 8. into x minus 1. Now we can write this as e power 2x into 1 by d into, split the fraction as 1 by 8 into 1 by 1 plus d by 8 into x minus 1 is equals to e power 2x into 1 by 8 into 1 by d into, we can write this as series of 1 by 1 plus x form, which we can write it as 1 plus x whole inverse. So we can write this as 1 plus d by 8 whole inverse into x minus 1. Right? This is equals to e power 2x by 8 into 1 by d into 1 plus d by 8 whole inverse into x minus 1. We'll expand this using 1 plus x whole inverse binomial series expansion. So before going to expansion, we'll find the derivatives of x minus 1. Okay. Derivative of x minus 1 is, derivative of x with respect to x is 1 minus derivative of 1 with respect to x is 0, right? Since 1 is constant. So 1 minus 0 is 1. Now find d square of x minus 1. We can write d square of x minus 1 as derivative of x minus 1. We have the value for derivative of x minus 1, which is a constant. So here the derivative of a constant with respect to with respect to x is 0, right? Derivative of 1 with respect to x is 0. So we'll get d square of x minus 1 is 0. Likewise, d cube of x minus 1 is 0. And d power 4 of x minus 1 is 0. And so on, right? In general, we can write it as d power k of x minus 1 equals to 0 for k equals to 2, 3 and so on. Right? So the higher derivatives of x minus 1 from 2 is 0, right? So that we have written k equals to 2, 3, 4 and so on. Now keeping this in mind, we'll expand 1 plus d by 8 whole inverse using binomial series expansion of 1 plus x whole inverse equals to 1 minus x plus x square minus x cube plus so on, right? Now just compare 1 plus x with 1 plus d by x. For x equals to d by 8, this is not x, okay, this is 8. For x equals to d by 8, we'll get 1 minus d by 8 plus d by 8 whole square minus d by 8 whole cube plus so on. This equals to 1 minus d by 8 plus d square by 8 square minus d cube by 8 cube plus so on, right? We know that higher derivatives from d square, the values of derivative of x minus 1 from square is 0, right? So we can neglect all the terms from here, because from here we are having higher derivatives d square, d cube, d power 4, x so on, right? So we'll take only the first two terms. Okay. Is equals to e power 2x by 8 into 1 by d into expansion of 1 plus d by 8 whole inverse is 1 minus d by 8. I'm writing this step here, plus d by 8 whole square minus d by 8 whole cube plus so on into x minus 1. Which is equals to e power 2x by 8 into 1 by d into 1 minus d by 8 plus d square by 8 square minus d cube by 8 cube plus so on into x minus 1, right? Since we know that higher derivatives from d square of cube is 0, right? Since d power k of x minus 1 is 0 from k equals to 2, 3 and so on. So neglect d square, d cube, higher derivatives or higher derivative terms from d square, d cube and so on, right? Then we are going to neglect all these terms. Exactly from the third term, we'll neglect. So we'll get e power 2x by 8 into 1 by d into 1 minus d by 8 into x minus 1, right? This is equals to e power 2x by 8 into 1 by d into 1 minus, we can write d by 8 as 1 by 8 into d for our convenience, okay? Into x minus 1. Then yp becomes e power 2x by 8 into 1 by d into 1 into x minus 1 is x minus 1 minus 1 by 1 by 8 into d of x minus 1, which is equals to e power 2x by 8 into 1 by d into x minus 1 minus 1 by 8 into, we have the derivative of x minus 1 value, which is 1, is equals to e power 2x by 8 into 1 by d into x minus 1 minus 1 by 8 into 1 is 1 by 8. Then this becomes e power 2x by 8 into 1 by d into, take the LCM, we'll get 8 in the numerator, x into 8, 8x, minus 1 into 8, 8, minus 1. This becomes e power 2x by 8 into 1 by d into 8x, minus 8 minus 1 is minus 9 by 8. Again, we can split this fraction as 1 by 8 into 8x minus 9. So take this constant towards left. We'll get e power 2x by 8 into 1 by 8 into 1 by d into 8x minus 9. We know that 1 by d is an integral operator. So later we'll perform integration. Is equals to e power 2x by 8 8 is 64 integral of 8x minus 9 into dx. Then yp becomes e power 2x by 64 into integral 8x dx minus integral 9 dx. This is equals to e power 2x by 64 into, take the constants outside the integral, 8 integral x dx minus 9 integral dx, which is equals to e power 2x by 64 into 8 integral x dx is x square by 2 minus 9 into integral dx is x, is equals to 2 4s are 8, right? So we'll get e power 2x by 64 into 4x square minus 9x. Also we can write this as 1 by 64 into e power 2x into 4x square minus 9x. These are required by P. Therefore, yp equals to 1 by 64 into e power 2x into 4x square minus 9x. We got yc and yp, so we can write the general solution now. The general solution is given by y equals to yc plus yb. Then y equals to yc, c1 e power minus 6x plus c2 e power 2x plus yp 1 by 64 into e power 2x into 4x square minus 9x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.